Today we're going to look at decimal operations, and we're going to be working with rational numbers, so that means our decimals can be both positive and negative. Now I know a lot of you are just going to instinctively reach for your calculators, and that's fine with decimal numbers. I think most of us do that. We've got a calculator generally on our phone that sits in our pocket all day, so this is one of the rare times I'll say using a calculator with these is not such a big deal. But what I would like you to be able to do is, if you had to do it by hand, can you? But the more important thing is, can you estimate and make sure that your answer is going to be reasonably close? Okay, so that's really what I'm looking for. So remember, when we are looking at, we're going to add and subtract first. So remember, if we are adding or subtracting, we need to make sure to line up our decimal points. As well, we're going to follow the same rules as adding and subtracting integers. So I'm going to follow the same integer rules that we've had. Okay, so for example, if I was looking at something like, we'll say negative 1.23 plus negative 4.5. Okay, so if I was looking at these two things, my first instinct should be I'm adding two negatives, I'm going to have a larger negative value. Right? I'm going to have a larger number portion, and so then it becomes just a smaller number, but I'm just going to combine my negatives together. So my answer is still going to be negative, and that's really the one part I want you to do by yourself. I don't want the calculator to do this part for you, because then you're messing around trying to put in the right plus and minus signs, and it's a real pain. Okay? So I know that my answer is going to be something negative. All right? So I'm going to add these two numbers together. So I got 1.23, and then I'm going to put my decimal point right underneath, because when I'm working with adding or subtracting, all my decimals need to line up. Okay, if you've got a blank space like we do here underneath the 3, we can fill in a 0 because 4.5 is the same thing as 4.50. And then we're going to simply add. So 3 plus 0 is 3, 2 plus 5 is 7, and 1 plus 4 is 5. Okay, so our two negatives came together to form a larger or a bigger group of negatives. Okay, so now we have negative 5.73. Okay, do another one. Let's say we've got negative 17.1 plus, we'll say positive 20.9. Or we'll say 20.09 so that we have a little bit extra work to do here. Okay. Alright, so when I'm looking at these two, my signs are different. And when I look and my signs are different, that means I have more negatives or more positives. So I look at the numbers. I got 17 negatives, I've got 20 positives. So I know I have more positives than I have negatives. So my answer in the end is going to be positive. Okay? Since the signs are different, I'm going to find the difference between them. So I'm going to take my positive, which had more than the negative, and I'm going to find the difference, which means to subtract. Okay, so again, I'm going to fill in a 0 underneath the 9 so that I don't have any empty spaces. And now I'm going to go 9 minus 0, which is 9. 0 minus 1, I can't do that, so I'm going to go borrow. So that turns into a 1. This turns into a 9. And then we've got 10 there. 10 minus 1 is 9. Decimal, decimal, decimal. 9 minus 7 is 2, and 1 minus 1 is 0. So we get positive 2.99. Okay, and that's the difference between them. Okay, now what do we do if we're subtracting? So subtracting looks very similar. So let's go back. We'll have a negative 1.73. And let's say minus positive 3.81. Okay, so I'm starting at somewhere negative and I'm taking away positives. Now you might remember with integers, one of the things you were doing was you were, instead of subtracting, you were simply adding the opposite integer. So I can do the same thing with rational numbers, and I can add the opposite rational number instead of subtracting. So I can change every subtraction to an addition statement. So now I have two negatives adding together. That means my answer is going to become a bigger grouping of negatives. And I've got 1.73 plus 3.81. And that's going to be 15, so we carry the 1 up. And then we get 5.54. Okay. And let's just do one more. So I've got, how about 1.2 minus 25.64. Okay, so if I'm doing something like that, this is a positive 1.2 minus a, and again this would be a positive 25.64. So if I want to rewrite it, where instead of subtracting, I'm now adding the opposite sign. So I'm going to add the opposite, and I now have negative 25.64. So I'm adding two things. They are different signs, so I'm going to find the difference between them. So I have to figure out which one I have more of. I have more negatives than I have positives, so I'm going to have negatives left over. My negatives then is the number I put on top, and I subtract the 1.2, and then I'm going to put in a 0. I'll put in a 0 so we don't have that blank spot, and now I've got 4, 4, 4, 2, so that's 24.44, and because we said we had more negatives than positives, it's negative 24.44. Okay. All right, so multiplying and dividing. So again, I am going to follow my sign rules just like we would with integers. So remember our sign rules: if we have two of the same sign, then our answer is positive. If it's a different sign, then our answer is negative. Okay, and if you're multiplying several things together, then remember an odd number of negatives is negative, an even number of negatives is positive. Okay, all right, so for multiplying and dividing, so you probably haven't seen doing this with decimals since grade 7, so it's been a while. So if I had negative 2.5 times negative 1.3, okay, so the easy part that I want you to take care of before typing these into your calculator, I want you to determine, is it positive or negative? So two negatives multiplying together gives me something that's positive. Okay. With multiplying and dividing, I don't need to line up my decimals. Now in this case it ends up working. Okay. So 3 times 5 is 15, carry the 1 up top. 3 times 2 is 6, plus 1 is 7. Cancel we're done with the 3, so cross it out. 0 underneath. 1 times 5 is 5, 1 times 2 is 2. And so now we have, this gives us this gives us 5, and then 7 plus 5 is 12, carry the 1 and we get a 3. Okay. Now in terms of placing the decimal point, so again you probably don't remember this from grade 7. So there's a couple of, there's a way that you can do it with a rule. I like to simply just use estimation because I think it's much nicer. If I look back here, 2 times 1, right? Because those are the numbers that are farthest left. 2 times 1, that's going to be somewhere close to 2. That answer then, down here, I need to put in my decimal point somewhere here so that my answer is close to 2. So if I put it between the 2 and the 5 and try to line it up, I get 32.5, and that is not very close to 2. Certainly not as close to 2 as putting it here between the 3 and the 2 would be. That gives me 3.25. That's very close. If I was to put it on the other side of the 3, if I was to put it here, that wouldn't make sense. 0.325. My answer shouldn't be getting smaller. I'm not doing any multiplying to make it smaller. Okay, so just using estimation, I know my decimal point has to go in between the 3 and the 2, so we get positive 3.25. Okay, now for those of you who want to remember the rule that you're probably taught, count how many decimal places there are in your two factors. So there is a 5 and a 3 for 1, 2 decimal places. So in my answer, I need to also have 2 decimal places. Okay, it doesn't matter which way you want to do it. I simply like using the estimation one. I think it's a little bit faster than trying to count out your decimals, especially if you know your times table. Okay. All right, let's do another multiplying one just to see. So we've got 12.3 times, and we'll call that a positive 12.3 times, negative 5.45. Okay, so with this one, I've got positive times negative, so that's negative. So if that's all you do and then you type the rest in your calculator, I can live with that. So you deal with the sign. Okay. All right, for multiplying these, I'm going to multiply them. I'm going to write the decimals in, but it doesn't really matter because I'm not going to count them. I'm just going to use my estimation at the end. So I might even do that now. So I've got 1 times 5, and this 1 is in the tens position. So it's like 10 times 5. 10 times 5 is 50. Now, that's probably a very low estimate because I don't have 10, I have 12, right? So if you want, you could go 12 times 5 is 60. That's an even closer estimate. So I know that at the very least, it's got to be 50, but probably bigger, okay? All right, let's go through the multiplication now. So 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus the 1 is 11, carry the 10 over, I should say. And then 5 times 1 gives me 5 plus 1 is 6. Okay, so we're done with that 5. We'll cross it out. And now I've got 4 times 3, that gives me 12. Carry the 10 to the next column. 4 times 2 is 8, plus the 1 is 9. And then 4 times 1 gives me 4. Crossing out the 4, now I got to have 2 zeros. And since I'm multiplying by 5 again, I already have that one from before. I know it's going to be 615. Okay, so I'm going to add everything together. 5, 3, this gives me 6 and 9 is 15, plus 5 is 20, so carry the 20 up top and put the 0 in. 2 and 4 is 1 and 7, and then we get 6. So I've got 6, 7, 0, 3, 5, and I said that my answer should be a little bit bigger than 50, so I need to put my decimal in between the 7 and the 0 to make it 67. Okay, so negative 67.035. Okay. All right, I'll show you a couple dividings. Even though you probably haven't done this dividing for a while, we can divide by decimals. So I'm going to go 0.132, we'll say negative 0.132 is being divided by positive 1.2. Okay, so opposite signs, negative answer. So if you type it into your calculator, I can live with that. But just in case you want to do it by hand, or if your calculator dies on a big test and you're freaking out. So I would set it up like this. Okay, so I'm going to do my long division. Now, when I'm doing my long division, it is a problem to have this decimal point in front. I'm going to move that. I'm going to move it over one space, right? So instead of working with 1.2, I'm going to work with 12. So I move the decimal place one space to the right. Essentially, I'm multiplying by 10. And if I do the same thing to both numbers in my division, I actually still have the exact same division statement. So if both factors grow by the same factor, I'll still get the same answer. So instead of working with 1.2 dividing 0.132, I'm going to work with 12 dividing into 1.32, and I'm going to get the same answer. Okay, so once I've got my division set up and I don't have a decimal point in front, I move my decimal point up and then I divide like normal. So can 12 go into 1? No, so I put a 0 up top. And now I look at 1 and the 3 combined, so can 12 go into 13? Yes, it goes in 1 full time. 1 times 12 is 12. I'm going to subtract that, and oops, and I've got a 1 left over. Okay, and then I'm going to bring down my 2 that I haven't used because 12 can't go into 1. And now I look at it as 12. Can 12 go into 12? Yes, it can. 1 full time. And 12 times 1 is 12, and I have 0. And as soon as I hit 0, I can't do, well, not as soon as I hit 0, but I've got no numbers left on the right-hand side, and I have 0 for my leftovers. So there's my answer, is negative 0.11. Okay, so again, you do the sign, your number can, or your calculator can deal with the numbers if you're more comfortable with that. Just do one last division for you. So let's say I've got negative 7.8 divided by, we'll say negative 0.005. Okay, so negative divided by negative is positive, so I know my answer is going to be positive in the end. If I was to write out 0.005 dividing into 7.8, okay, I don't like that decimal in the front, so I'm going to move it 1, 2, 3 spaces to change my number into a 5. But then I got to move this decimal 1, 2, 3 spaces, and I have these empty gaps. Okay, so again, remember, moving it 3 spaces is like timesing by 10 3 times. So if I go 7.8 times 10, I get 78, times 10 again is 780, times 10 one more time gives me 7,800. Okay, so now I don't even have any decimals, and I'm just working with whole numbers. So 5 can go into 7 one time. 1 times 5 is 5, and then I subtract, I'm left with 2. I'm going to bring down that 8. 5 can go into 28 5 full times, and 5 times 5 is 25, and now we have 3 left over. Bringing down the 0, 5 can go into 36 full times, and 5 times 6 is 30, and I have 0, but I'm not done, because I still have this other 0 I have to deal with. My decimal point is here, so I got to fill this in. So 5 can go into 0, 0, 0 times, so I put that in. My leftovers are 0, so my final answer is 1,560. Okay? Alright, so that's adding, subtracting, multiplying, dividing, rational decimals. Okay, so decimals that can be both positive and negative. So really, we follow our sign rules the same as we would for integers, and decimal operations don't change. We still do the exact same decimal operations we did before. Keep in mind, I'm totally fine if you use your calculator. I think most adults would say that they do use their calculator for decimals. So again, what I want you to be able to do is I want you to be able to know the sign that is going to be your final answer. You should be able to work that out in your head, and as long as you can do that, the calculator can deal with the numbers. All right.